Hi GOR, this is Unit 4, Lesson 4, and today we're going to talk about similarity transformations. So I have a picture of triangle EFG, which is right here, the smaller one, all right? And triangle E prime, F prime, G prime was constructed after a scale factor with a scale factor of 3, after a dilation with a scale factor of 3. So basically all I did is I took point G, which was right here, and I drew some lines going in both directions, and then I just, see how I just went 3 times as far away, and this is my new point E prime, and this is my new point F prime. So you use your compass to do that. That's something that was already done for us, and you don't need to worry about doing it. But the question is, what is the relationship between the sides of the original figure and the sides of the scale drawing? Well, if I did a scale factor of 3, then the image is 3 times as long, or the original is 1/3 of the scaled. And the big important thing is, what's the relationship between the angles of the original figure and the scaled figure? If I took out a protractor and measured angle F and angle F prime, and angle G and angle G prime, and angle E prime, those angles are the same. They're all congruent to each other. Remember, the angles of a triangle equal 180 degrees. The image is also 180 degrees. It's not that those angles got 3 times as big. We call these figures similar. Okay, and that's what we're talking about today, similarity transformations. So in similar polygons, the angles are congruent, equal, and the sides are in proportion. So those are the 2 concepts that you really need to know. The angles are congruent for similar figures, and the sides are in proportion. So similar means that they're the same shape but not necessarily the same size. So if you look at a picture right here of 2 similar triangles, this is my symbol for similar, that little like sideways S. Triangle ABC right here on the left is similar to triangle DEF. So if you notice, the angles are congruent to each other. Angle A is congruent to angle D. Those are right here. Angle B is congruent to angle E. And angle C is congruent to angle F. The angles are congruent. The sides are in proportion. If you look at each of these sides, like the AB and DE, AB is 6 and DE is 9, 6/9, okay? And if I was to reduce 6/9, 6/9 reduces to 2/3. And if I take the 3 and the 4.5, it also reduces to 2/3. All of these sides reduce to the same number. 4/6 reduces to 2/3. Okay, so those sides are in proportion to one another. I can actually make a proportion, and we're going to do that more probably in the next unit. We're going to set up proportions and solve for the missing side. But for right now, you should know the angles are congruent and the sides are in proportion. So the symbol for similar is that little sideways S. And to be similar, it means that they are similar to the congruent symbol we used. So the congruent had the equal sign with that little sideways X. But unlike congruent, the similar does not mean that they have the same size. We see that the sides are in proportion. The angles are congruent, but the sides are not congruent to each other. They're in proportion. So that's why we don't use that equal side. Similar figures are figures that have the same shape, but not necessarily the same size. All right, let's look at the transformation that would map this pre-image of this house on the left to the pre-image of that house on the right. Okay, what are my transformations? Remember, we did reflections and rotations and translations. So if you look at the figure, the house on the left, the chimney's on the right, but in the other house, the chimney is on the left. So I must have done a reflection. I flipped it. But I also shifted it. See how I moved it over and up? So I moved it to the right and up a little bit. So those are the 2 transformations that I did. I didn't rotate it because I didn't turn it, and the size is exactly the same. All right, so these figures are actually congruent. Why are they congruent? Because remember, a reflection and a translation are both rigid motions, and they preserve the length and the angle measure. So reflection and translation. So this is what we talked about back in Unit 2 and Unit 3. Reflection and translation are both rigid motions. They preserve the length. And the angle measure, but the length is more what we're going to be focusing on here. Now let's look at these two houses. Let's define the transformation that would map the pre-image on the left to the image on the right. Well, on this one, you can see that the house got smaller, all right? So I definitely did a dilation. I changed the size of it. What do I know about these figures? They're not congruent. They're not the same length. One of them got smaller. We say they are similar to each other. So polygons are similar if their corresponding angles are congruent. That means they're the same, they're equal, and their sides are in proportion. That's what it means to be similar. Two figures are similar if there is a single transformation or a sequence of transformations that include translations, reflections, and rotations and dilations. So to be similar, there has to be a similarity transformation that maps one onto the other, and that can include dilations. All right, so here's a little summary right here. So my rigid transformations, the ones that are going to result in congruent figures, are my translations, my reflections, and my rotations. Those have the same shape and the same size. They're congruent. My similarity transformations are still the translations, reflections, and rotations, but now I'm adding in dilation because I'm going to change the size of them. So those are not congruent. They're the same shape, but they are not the same size. So I say those are similar to each other. All right, so in exercise 4, we have this little Pac-Man kind of shape right here. And it says figure A is similar to figure A prime is similar to figure A. Which transformations compose the similarity transformations that maps figure A onto A prime? Well, it got smaller, so there definitely was a little bit of a dilation. And if it got smaller, that means my dilation was less than 1. All right, but I reflected this. I flipped it. I didn't turn it, right? It's not actually a rotation because then the smiley face would be faced in the same direction, but I did a reflection. Okay, so these would be similar to each other because there is a similarity transformation that took place, and in that case it was a dilation and a reflection. Is there a sequence of dilations and basic rigid motions that would take the small stick figure to the large stick figure? Well, let's look at them. The answer here is actually no. These are not similar to each other. Now here's why. If you focus on the bodies are actually the exact same height. All right, the only thing that changed is the heads are a different size. So they are not in the same ratio. The bodies are the same. The heads changed. But to be similar, everything has to be in the same proportion. And that is not true for my stick figures here. Just so you can see it a little bit more easily in exercise 6, I want to know if the triangles are similar. Is there a transformation that would map one triangle onto the other? And there is, because you can see that, look at the sides, if I compare them, 8 became 16, 10 became 20, and 6 became 12. Okay, so what I did is I dilated it, okay, by each side was twice as long. So it was a dilation, the scale factor of 2. And then I just translated it. But both of those would result in the figure being, translation, would being similar, all right? Each side is twice as long as the other side. All right, and that was it. We'll practice that tomorrow.